In this video, we are going to discuss number 8. It says the following data is provided with regards to the students' patronage of 4 snack booths according to the following distribution. So there seems to be a factor affecting the manner in which they patronize the booths. Okay, so you are given the task of testing the following hypothesis. And the hypothesis is there is a factor affecting the manner in which the students patronize the snack booths. So the hypothesis is that the patronage of the snack booths is not a random process. So this is clearly a chi-square test for randomness to see if whether or not the distribution of the students with regards to the snack booths is a random activity. So here you have the chi-square critical value, 11.345, the chi-square test statistic formula, and the formula to calculate the expected value, which is the sum of the observed over how many snack booths were observed, n. So you must state the pair of hypotheses. So the null will be saying there seems to be no factor affecting the manner in which they patronize the booths. So in other words, the distribution is random. So that's what the null will always say for chi-square test for randomness. And the alternative hypothesis will say there seems to be a factor affecting the manner in which they patronize the booths, or the distribution is random. So the null will say the distribution is random, and the alternative will say that the distribution is not random. So this is a little typo right there. So I repeat, the null will say the distribution is random, no factor affecting, and the alternative will say that the distribution is not random. There is a factor affecting. So here's the data, and here's how it was processed. 4 snack booths were observed. 80 went to one, 75 went to the other, 85 to the other, and 90 went to the other. So that is what was observed. So the expected values will be the sum of the observed divided by n. 80 plus 75 plus 85 plus 90 divided by 4. So we got an expected value of 82.5. So now here it is laid out, and now we can calculate O minus E all squared divided by E. These are called the chi-square contributions. So here they are all calculated. 80 minus 82.5 all squared divided by 82.5, 75 minus 82.5 all squared divided by 82.5, etc. up to 90 minus 82.5 all squared divided by 82.5. And they will add it up to give you the chi-square test statistic. And here you have the distribution curve. For the chi-square, the curve will always be skewed towards the right, unlike the z-test, which will be a normal curve, which can be both left tail, right tail, or two tail. For the chi-square will always be skewed towards the right. The critical region will always be on the right, as you can see, and the critical point will be on the right. So now we have the critical value on the critical point, and the test statistic, which is 1.515, is closer to 0. So as you can clearly see, the test statistic is not in the critical region. So you need to take out your pencil, your pen, your paper, your calculator, and to actually perform the test as a means of practicing. Now, since the test statistic is not in the critical region, the decision is not to reject the null hypothesis. So this null hypothesis here was not rejected. So therefore, it will be the conclusion. So in conclusion, based on the data, there seems to be no factor affecting the manner in which the students patronize the books. In other words, the distribution is random. So please rewind, pause, and actually perform the test as a means of practicing.